So I'd like to introduce Arun to kick it off.
Thank you. All right, so my name is Arun. I work on Uber Eats. Who here has tried Uber Eats? All right. So 2 years ago, there was a lot fewer hands. It's exciting. So I'm here to talk about the restaurant team. We use Uber Eats a lot in that team. I've had the pleasure of working on that team for about 7 or 8 months. Before that, I managed a very different team that was all native engineering. Okay, so I work on Uber Eats. So hopefully, it sounds like a good number of you have tried it before. If not, hopefully you'll try after this awesome talk. So before I kind of dive into how we use React Native, I think it's very important to understand the context within which we use it. Uber Eats is actually seemingly a very straightforward product, but there's a lot of really hidden complexity behind the scenes. But before we kind of dig into the complexity, let's talk a little bit about the history. The idea is making eating well effortless at any time for anyone. Push a button, get an awesome meal. It's affordable, it's reliable, it's healthy. That's the goal. We'll get there, but 2.5 years in, we've achieved a good portion of that. So it started in 2014 as a lot of good things at Uber start as like an experiment. What if we just put a few fixed menu items in an app and let people kind of like order them between the hours of noon and 1:30, see what happens. People want meals, 5 minutes, find really awesome restaurants, see if it works. Scaled it a little bit in 2015 to a few more cities. Launched the standalone app in 2016, and then 2017 is really when we kind of like knew that we found product market fit. On the left, you'll see these screenshots are literally like 2.5 years old, and they look so old and like dated. On the left, you'll see how we first started this. Uber Fresh was the original brand, and the metaphor is so broken because you want a car or a sandwich. It's like such a weird question to ask someone, but it worked. It was like a nice like early way for us to test it. On the middle screen, you can see like people with sandwiches that are available that are close to you. There's a shelf life of like 30 minutes after which that meal is no longer available. But these were ways at which we were able to like experiment and find some product market fit. On the rightmost, you'll see an older version of the app that we launched in December 2015 in Toronto, our first city. And that's just like a standalone app for consumers where they can download and order food. So Uber Eats is actually a 3-sided marketplace. Marketplace is actually a pretty like important concept at Uber. So Rides, which many of you know Uber for, is a 2-sided marketplace. You have the driver that's providing a service for the rider, and Uber makes a match and makes that as efficient as possible, make sure that quality is enforced and all sorts of good things happen. And on the Eat side, it's a 3-sided marketplace. You have the eater that's ordering from their phone or a web app. Order goes to a restaurant prepares the meal. Courier and delivery partner, we use that term interchangeably, arrives to do the pickup and then drops it off at the eater. So 3 different parties, and Uber's in the middle trying to mediate that and make sure everything's awesome for all the different parties involved. So lots of different software is needed. So probably when you sit at home and order food, you're probably not thinking of all the different things that are happening. The industry is not new. I think people have been ordering pizza by calling a number for a long time. So this is not a new concept, but the efficiency and the scale of it, in my mind, is truly new. I got rid of my car in 2010. I really hope that by 2020, I don't need to have a kitchen. That'll be an interesting life goal for me. We'll see if that happens. Hopefully I work on something that makes that happen, right? So I work on the restaurant side. So this is the restaurants. These are kitchens. These are large restaurant chains like McDonald's. These are small artisan like bakeries in the corner that operate for a few hours. They're looking for new eaters, new audiences for their product. We help. And that's what our app looks like, an older version of the app. A newer version of the app is a little bit more colorful, built in React Native. This is what we'll be talking about a lot about. And it's actually like quite a nice app. I couldn't do a live demo, we only have 10 minutes, but kind of want to at least show you what the app looks like. There's nice transitions. It looks nice. It feels nice. It's a tablet app. So you can imagine a kiosk or a little table in the restaurant where this is running, where a new order comes in, tells the restaurant what order to make and how to be ready. So there's also, very quickly, I used to work on the delivery app. This is the courier app. So you can imagine lots of complexities there in like wayfinding, parking, getting out of the car, picking up the food, dropping off the food. So that's an entirely different side of the marketplace. Just want to show you like all the different software that kind of goes through. kind of wanted to show what the app looks like. I think a lot of times people, when they hear React Native, they imagine like a watered down web app, a watered down mobile app. I didn't have lots of awesome screenshots that had private information scrubbed. So I just literally took screenshots from our user manual. These are good screenshots. But if you imagine, these is a nice PDF cutout from a manual that we give to restaurants. So new orders come in. They are, they animate, nice sound displaying. It tells you that you should accept the order. It shows up in a list of orders to prepare. When you tap into an order, you see the order details. This is super critical that we show the right information here, because if you ordered a burger without cheese, if it shows up with cheese, that's really bad. Food is very emotional, as we found out. People get hangry very quickly. So super important not to screw up these things. There are a lot of like workflows that you can kick off from there, look at details. We've organized it using a left menu where you can kind of quickly transition between all the different sections. In progress section shows you what orders your kitchen is supposed to be making. We have a lot of details about the timelines we expect the burger or the pizza or whatever to be ready in. So that's all kind of tracked within the app. So a lot of different state being managed. And when things are ready to be picked up, these are couriers that are arriving to pick up the food. So we kind of show that information on the right panel. So the left panel is all the orders, right panel is all the people that are arriving to pick up the food, and the middle is sort of the matchmaking that happens as far as the restaurant's concerned. So you hand off the order, and off they go. So you can see that the courier on the top is 4 minutes away. So it kind of tells you, hey, you don't want the courier to wait. You probably don't have space within your restaurant for them to wait. So just kind of managing the seconds and minutes of the order workflow is super important. A good chunk of our deliveries now happen within 30 minutes. Goal is to keep driving that down. Imagine how often you'll order if we can have that food delivered to you within 15 minutes, right? So that's sort of the long-term goal there. Order history, see what's been delivered, details of that, receipts, get support, and all of that, right? So pretty rich app, multiple screens, a lot of different transitions. Dive a little deeper into the app a little bit, talk a little bit about the architecture. So this app, right? So kind of said, if you think about the three-sided marketplace, in many ways, like the Eater app and the Rider app, they're very analogous in that these are consumers that want a quality product. They understand the Uber brand. The Driver app, it's actually the exact same app that your drivers use on your car. That was super important for us because in many cities, we actually use drivers to actually deliver your food, right? So there's a new Eater app, a native mobile app, because there was a bunch of new things we wanted to try there. React Native was a little too much of a risk for that team to take on. So restaurant team, on the other hand, was staffed by web engineers. This is before the team moved to New York. There's a bunch of web engineers that had built a web dashboard. And we said, how about React Native? The decision didn't come naturally. We actually tried to just ship a web app with the home screen icon to these tablets. Lots of really interesting discoveries, which I'll talk about. So this talks about scale. Talk a little bit about scale, big and small. 6 engineers right now in New York that are working on it. We support all sorts of different tablets and also web, which Leah will talk about after. 120,000 restaurants that are active weekly. That's from a month or so ago, so a bigger number now. 35 countries, 280 cities. $6 billion a year run rate as of the first quarter, so that number is also bigger. So that's $6 billion worth of food sold through the app. So kind of if you look at sales of these big chain restaurants, that number will be actually quite interesting to compare. But we still think the market is super nascent, so we have to build for more growth, multiple times of the growth. There are still restaurants that receive orders via fax machine. So you can imagine the digitization and the difference that'll make. So we're building for that growth. When we first launched the tablet app, it was, as I mentioned, a home screen icon that launched into web view. Lots of really interesting challenges. It was on iPad 1, which was, 6 years ago that we just picked up a device that had a reasonable price point and we gave it to restaurants. And web apps and Safari mobile back in the day just didn't work well. We had this really weird problem where it would not play sound unless you interacted with it. So we had to do all these crazy hacks where we had to invite some interaction before sound was played. We said, this is crazy. Let's just go something that's a bit more native. So the migration path kind of began. So we said, okay, we have all these web assets. It's a React Flux-based app. why don't we just wrap the UI part in WebView and then start to implement all these native layers for sound, for printing, for just being efficient with the network and things like that. So we started by having a WebView for the UI wrapped in a React Native app. That was the first step. Then we said, why don't we just get rid of the WebView and build a fully native UI using React Native? So I guess a React Native UI. And that's what we have now. We have a native app that is no longer using WebView, but this is sort of a step one for us that let us get there. A lot of interesting discoveries. So at Uber, for instance, we have a bunch of native mobile apps, driver app, rider app, eater app, freight app, many other apps internally as well. So we have a lot of libraries. We have a lot of libraries for things like analytics. We have a lot of libraries for things like crash reporting, authentication, logging, all that stuff, right? And one of the things we realized that in some cases, it makes sense to just rewrite those libraries in pure JavaScript. One of the lessons learned for us along the way was, yes, you want to reuse a lot of your native libraries, but being able to reuse the same code between two platforms is a bigger win and less context switching and fewer surface areas for bugs. So if you have existing libraries that's on iOS or Android specific, unless there's a real reason for it, for analytics, for instance, it was just a simple network call. We can do that in JavaScript. So we kind of rewrote some of those things. Same for some like WebSocket-based stuff that we just rewrote. One of the coolest things is we use code push. This is before some of the more popular services like Microsoft's code push existed. So we just kind of built our own code push. It works. It's okay. But we probably will do some more interesting things there. So we use Fabricator, Facebook's open source, like source control management and task management tool. So we land code, Jenkins builds it, packages up all the JavaScript bundle and pushes it S3. And then on the app side, when the app starts, it checks to see what the most recent available bundle is. Actually, I should show this one before and replaces it. So at any given time, the app actually has 3 bundles. The bundle it was built and shipped with, the native layer has a JavaScript bundle it ships with. The latest stable bundle that it knows about. Bundle is just a fancy word for a bunch of JavaScript. And also a bundle that it can download from S3, which is really awesome because we can ship code very quickly and efficiently. However, as I mentioned before, this is an app that restaurants use for their workflow. It has to not just run, it's not like the rider app, right? Where you open the app, you press a button, car shows up, you back around the app and you go do something else. This app has to be up and running on the foreground for days at a time, right? Restaurant staff turns over a lot. You don't want to train these people on starting up a new app or logging in. It has to be up and running the whole time. So any JavaScript crashes, which is super easy to do if you've written JavaScript, it's super important that it's like very stable, right? So we have this whole process where we check to see, is the bundle, is there a missing reference in there? Did we have a typo somewhere? Even through all existing tooling we will have to have this safety check and fallback mechanism. We use Flow, super important for type checking. Some of the teams are experimenting with TypeScript. We're pretty happy with Flow. We use Sagas. So one of the things that's really interesting about our app, as I mentioned before, is it has to be running for days, not minutes or hours. And to keep an app running for days is a different mindset of thinking. So these long-running processes. So in this case, it just every few seconds, every few minutes, it checks to see are there new orders, right? And if it doesn't, it makes a failure call. So it's a generator function, uses fancy ES6 semantics, but Redux Saga is super awesome. I hadn't really used it before. I don't really program as much as I normally used to do before as an engineering manager, but it's like super nice to read this code compared to what this might have looked like with a different pattern. So this is the Saga that's referencing a different Saga. So what this does is basically looks for only do the repeating of fetching orders when you're logged in. And when you're logged out, stop that, right? So this is such a succinct syntax that error checking and all that becomes super easy. And you don't have to worry about crazy amounts of like memory leaks and stuff. And then you can kind of like extract that even further to like this really nice, like reusable higher order function. I won't go into that. Talk a little bit about hardware. So we ship our hardware to these restaurants. I mentioned 120,000 plus restaurants, numbers growing. We give them a nice box, contains one of many possible tablets. Tablet is determined based on the region In some regions, it's super hard to acquire an iPad. In some regions, it's super easy to acquire refurbished hardware, right? So that's next to my desk and next to a radiator, all the different types of tablets we test and support. We also supported a bunch of different types of printer. So I mentioned fax machines. So printers and paper are still super critical to the restaurant workflow. The ticket-based approach of like something comes out of my orders, I need to stick it next to the cook. So super important. We support all these different types of printers. Some like the tiny printer on the left is actually many times faster, cheaper, efficient than the big printer on the right. However, the big printer on the right is sold by a very popular POS vendor. So like there's some entrenched things we have to support. Restaurant industry is like, still in many ways nascent to the technology side of things. So these are two different types of printing technology, interfaces. On the left, you can see much nicer to look at, differentiation in font. On the right is a lower quality printer we have to support that actually we have to like paint those vectors and like, actually print it out. So that requires native interaction. We do a lot of that. Everything isn't always super great with React Native. We love it. We've been very happy with it. We've scaled it. Want to talk about a really quick problem and then I'll wrap up. So we had this issue where a large restaurant chain that's a customer of ours had this problem where after about a day, they upgraded to a new version, I should say. New version, you think it's going to be great. They're excited. You're excited. They upgrade to it. And after about a day, the app crashes. Basically stops taking orders. That is terrible, right? Like, the app is not. So as an eater, I no longer see that restaurant if the app crashes, if it's not online. So jump ahead to some of the lessons here. Debugging remote software is hard, especially like when it's so specific to a restaurant. It's a lot of different environmental things there. So I'll talk about that. Definitely need a lot more metrics. We learned a lot about what kind of logs and additional things to emit. And the React Native Objective-C bridge, especially on an iPad, is painful to debug. So I explained what the problem was, right? But I should also add that this was an iPad mini 1, half a gig of RAM, 6-year-old device, lots of really interesting lessons to be learned from debugging this. So a lot of red herrings, right? So we go in, we're trying to figure out what's going on, right? Is this a memory issue? Is it a network issue? Is it a CPU issue? Are we doing something that's so crazy? Is it a React Native issue? Is it an Uber code issue? So debug builds, if anyone's used React Native debug builds, it's super easy to get it to leak memory because it just kind of like evaluates JavaScript on the fly. It's just not useful for profiling. So you cannot profile debug React Native builds, which sounds really simple and like, retrospective, like it's really simple, but it was a big deal. We found a couple of bugs that we thought was the issue. We push updates, still happening. We also know that this restaurant chain has a captive Wi-Fi network. So we're like, is it hopping on a bad network and we're losing network connectivity and that's why it's crashing? Or that the network connectivity error message is not as like visible and restaurant staff is ignoring it. We knew it was a memory leak because we had memory warnings that we were logging. So that was helpful. That's our Grafana dashboard. The half a gig of RAM, you can see how if an app just at startup takes 100 megs, very easy to kind of go over. Xcode profiler, like the instruments, the memory view basically says no leaks. You can't see the screenshot on the right, but it says no leaks, which is a lie because we turned out it was definitely a leak. So we would run it for hours. I was like nights and weekends looking into this, nothing found. The native JavaScript debugger that comes with React Native said there's no leaks. We were like going into like malloc zones. So one of the engineers that was working on it, his father was like this crazy like memory guru and took us, we were like looking into all sorts of weird things. And then finally we saw that like this WebKit memory thing is like slowly creeping. It's like 45 megs in the screenshot, but it slowly creeps. And then we took a bunch of snapshots and then used the Safari debugger to actually see all the different snapshots. You can see that it's, growing by like quarter meg, roughly speaking. And then finally, we figured it out that we had an array with a bunch of callbacks just accumulating. Some animation that we were doing was just like collecting callbacks. So the animation happens to be that nice flashing greens screenshot I showed you. We were super proud of it. Turns out it leaks memory. So we think it was a GitHub. We logged a bug and they said we're using it wrong. Documentation certainly didn't say that you should be using animated.sequence and animated.timing is bad. So basically the fix was like After probably like, I don't know, 6 weeks of just pulling our hair, we fixed this. I know for a fact if this was purely an Objective-C or Swift or Java, we could have figured this out much sooner. The memory debugging tools are much better. The infrastructure is just nicer. So these sort of weird bridges is when things get bizarre. So yeah, we started using React Native 3 years ago. We still love it, but there are some lessons that you have to learn. Some of them in the sort of the weird seams when you push the envelope a little bit. The most important thing is that, you know, we are finding leverage. Like we started with iOS and iOS only. We're able to go to Android very quickly. And then as the next speaker will show, that we were able to go to the web very quickly. The most important thing the second most important thing I'll call out is that the team dynamics matter, right? If your team is like full of iOS engineers or Android engineers, this is a weird thing for them to take on. So we were lucky in that we had a lot of web skills and React Native made a lot of sense. So that's my talk. Thank you.